Good morning, my little marshmallow peeps. Today we are going to finish chapter 10, which means next Wednesday, you'll have your chapter 10 quiz. So, let's do a brief review since it's been a few minutes since we were together last doing lectures. So, remember, we started chapter 10 by going over the mole, which is a measurement of matter. We went over the rules for significant figures, which was all just a refresher, so I'm not going to go over that now. We talked about how we can convert amongst count, mass, and volume, and how that relates to the mole, which is the specified number of particles that chemists use, like a dozen. So remember, 1 mole of a substance is Avogadro's number of representative particles of that substance. A mole is actually an SI unit. We looked then at molar mass, and we did lots of problems with that. So remember that 1 mole of any element contains this amount of atoms of that element, but which has more mass, 1 mole of carbon or 1 mole of oxygen? We did lots of problems like this, and remember that we use the, example problem. Well, we use the molar mass of an element in order to determine the mass of a mole of that element. Remember that the molar mass can be found on the periodic table. For example, hydrogen, its molar mass is 1.008 grams per mole. So that means that 1 mole of hydrogen contains 1.008 grams of hydrogen. It has a mass, 1 mole of hydrogen has a mass of 1.008 grams. So we did all sorts of different stuff. We determined the mass of a mole of an element. We determined the mass of a mole of a compound. We looked at stuff like glucose and bigger compounds, not just one single element. We looked at compounds that have multiple elements in them, and we determined the molecular weight, remember molecular weight, of this compound based on the molar masses of each of the elements and how many of those elements constitute that compound. So for example, in glucose, we have 6 carbons. So we multiplied 6 times the molar mass of carbon, which is 12.011 grams. So that gave us this, which is the amount of carbon, the mass of carbon that's in glucose. We did the same thing with hydrogen, did the same thing with oxygen. We added them all together and found that the molecular weight of glucose is 180.16 grams per mole of glucose. Then we did so many practice problems. It just expanded on what we were talking about with molar mass and molecular weight. We found that we can determine the amount of one particular element in 1 mole of substance. We did that also using the molecular weight, also using the molecular mass. Not going to go over this entire thing again. If you're still struggling with that, you should go back to this last lecture for 10.2 and you should watch it again so that you know what I'm talking about. All right, now we're moving on today to 10.3. It's a short section. Okay, 10.3 is about percent composition, and it's also about chemical formulas, but we're not going to go into that part of the chapter or the section, so that's why it's a little bit shorter than it was in your reading. So let's jump right in. The percent composition of a compound. What does that mean? The percent composition of a compound is the percent by mass of each element in that compound. So very importantly, the percent composition of a compound, of any compound, of one particular compound is always the same no matter what. So let's look at some examples that will make this a lot clearer. So we're going to do a non-chemistry example to start. We're going to look at the percent composition of students in our class. All right, so what percent of our class is in the 10th grade? So the percent of 10th graders is equal to the number of 10th graders, which is 11, divided by the total number of students, which is 13, and we want this in a percentage, so we have to multiply it by 100. That gives us 85% of the class is 10th grade. Therefore, 15% of the class must be 11th grade, right? Because it has to equal 100%. So 85% of the class, 10th graders, 15% of the class, 11th graders. So this is a very simplified version of percent composition. We have two different things we can do with percent composition. We can find the percent by mass. Well, let's say we can find the percent composition by using mass data, which just means the masses of the elements. Or we can find the percent composition using the chemical formula. Mass data and chemical formula. So these are the two different ways that we can find our percent composition. There's going to be two different kind of equations that we're going to use. They're very similar to solve for these two things. So for the first one, the percent composition by mass of elements is going to be equal to the mass of the element divided by the mass of the total compound, mass of compound, times 100. All right. If we want to find the percent composition using the chemical formula, we're going to do the same thing, percent by mass of element. But now we're going to do mass of the element in 1 mole of compound divided by, I'm going to scooch that, divided by the molecular weight of the compound. And we'll multiply that also by 100. Okay, so maybe that looks a little confusing. We're going to do some examples with both of these. Don't you fear. So let's look at some example problems. Okay, so here are the two examples. So the first one says, when 13.6 grams of a sample of a compound containing only magnesium and oxygen decompose, 5.10 grams of oxygen are obtained. What is the percent composition of this compound? This is an example of composition using mass data. We're only given masses here, right? As opposed to the second example that says propane is a commonly used fuel. What is the percent composition of propane? So in this situation, we're not given any mass data. We're only given the chemical formula. So in this case, we're going to use this equation. So we're going to solve both of these problems on the next page here. All right, so let's do this one first. So when we're given all of this mass data, remember that in order to find the percent composition or the percent by mass of an element, when we're given mass data, we're going to do the mass of the element in question divided by the mass of the total compound multiplied by 100. So if I want to know, first I'm only given this information, 5.10 grams of oxygen. So the percent of oxygen in this compound is equal to 5.10 grams of oxygen divided by 13.60 grams of our compound. We don't know the chemical formula for our compound, so we don't know what to write there. We don't know if it's we said MgO. That's probably what it is, but we don't know that. So and then we multiply this by 100, and we get that this compound is made up of 37.5% oxygen. If we are using our brains, we can say that we can just find the percent magnesium by subtracting this number from 100%. When we do that, we find that the percent magnesium is 62.5% magnesium. So our percent composition, how I would report this, is that this compound contains or is made up of 37.5% oxygen and 62.5% magnesium. Well, that's it. Yeah. So let's do this one now. So remember that for this one, for this type of problem where we're only given the chemical formula, we're not given any mass data, we're going to use this equation. We have the percent by mass of the element is equal to the mass of the element in 1 mole of compound divided by the molecular weight of the compound. So let's look at what this means. So let's find first, just arbitrarily, I'm going to find the percent of carbon in this compound. So first I need to know the mass of carbon that's in 1 mole of propane. So in order to do that, I'm going to have to look at the molecular weight, right? So the molecular weight, let's look at carbon first. We have 3 carbons multiplied by 12.011 grams per mole of carbon. This gives me 36.033 grams per mole of carbon. For hydrogen, we have 8 times 1.008 grams per mole. This gives me 8.064 grams per mole of hydrogen. When I add those two together, I get that the molecular weight of propane, oops, that's too big of an 8, is equal to 44.097 grams per mole. Okay, so I'm going to have to use this information in order to solve for my percent carbon. So the mass of carbon in 1 mole of propane is 36.033. I divide that by the molecular weight of the compound, which is 44.097. Multiply that by 100, and I find that this compound is made up of 81.7% carbon. That means that if I subtract 81.7 from 100, I get that 18.3% must be made up of hydrogen. So there's my percent composition for that. Well, these were pretty simple. There was only 2 elements, right, for each of these compounds. What about if we have a compound with more than 2 elements? So what about this question here? A 61.1 gram sample of ribose sugar, here's the formula, contains 24.44 grams of carbon and 32.5663 grams of oxygen. What is the percent composition of ribose? So what we're going to need to do first is let's determine the percent composition of carbon. We know that there are 24.44 grams of carbon in the 61.1 gram sample. Multiply that by 100, and we get 40% carbon. Now let's find the percent oxygen. We have 32.5663 grams of oxygen divided by 61.1 grams of ribose altogether times 100 gives us 53.3% oxygen. So what is the remaining amount of, what's the percent of hydrogen here? Well, we add 40 plus 53.3, and then we subtract that from 100, and we get 6.7% hydrogen. So this is the percent composition of ribose. I could also give you this problem the other way around, like this, for example. I could give you the percent composition of ribose. We just found it, but I could give it to you. It's 40% carbon, 50% oxygen, and 67% hydrogen. And then I could say how many grams of carbon, oxygen, and hydrogen are in a 14-gram sample of ribose. Well, what we're going to do is we're just going to do we're going to rearrange this equation to like this. We're going to rearrange this so that we are isolating the mass, where's my pointer here? The mass of the element. So we're going to multiply, so let's do this. We're going to do, for example, carbon. We would say the percent of carbon times the mass of the compound divided by 100 is going to equal the mass of our carbon. So let's look at that. We have 40% carbon times the mass of our compound, which is 14 grams, divided by 100 to make it no longer a percentage. This is going to give us the mass of carbon. This gives us 5.6 grams of carbon. We can do the same thing now with oxygen. The percent of oxygen is 53.3% oxygen times the mass of the compound, which is 14 grams, divided by 100 gives us 7.462 grams of oxygen. And if we want to do, we could just add this and this together, and that would be 13.062. We subtract that from 14, and that would give us 0.938 grams of hydrogen. Or if you wanted, you could just do it the same way that we've been doing it. We would say 6.7% times 14 grams divided by 100, and this will give us 0.938 grams of hydrogen. So there we go. I can give you these problems either way. Let's look at this last problem before we call it quits on chapter 10. So please calculate the percent composition of sodium hydrogen sulfate. I hope you're seeing how this unit exam is going to go, because this is just a beautiful question. It's applying things from two different chapters. Calculate the percent composition from chapter 10 and a compound name from chapter, 9? So, FYI, you've been warned. Look out, y'all. Okay, so a reminder, sodium hydrogen sulfate. That is sodium hydrogen sulfate, also called sodium bisulfate if you're interested. But anyway, so calculate the percent composition of sodium hydrogen sulfate. So what we're going to do first is sodium. Let's find out the percent sodium in this compound. Before we can do that, though, we actually have to find the molecular weight and all of the components of sodium hydrogen sulfate. So let's find sodium first. Sodium has a molecular mass of 22. Well, let's do 1. 1 sodium times 22.990 grams per mole gives us 22.990 grams per mole. Then we have hydrogen. We have only one hydrogen. So that's going to be 1.008 grams per mole. And 1.008 grams per mole. And then we have sulfur, same, just one sulfur, which is 1 times 32.06 grams per mole. Well, we don't have to rewrite this every time, but I'm doing it because I have a little bit of a problem with needing to do that. And then we have oxygens. We have 4 oxygen, which is 15.999 grams per mole, which is 63.996 grams per mole. Okie dokie. We add all of these together, and we find our molecular weight is equal to 120.054 grams per mole. Okay, now we are prepared to find percent sodium, percent hydrogen, percent sulfur, and percent, I ran out of room. Percent oxygen. All right. So first we have sodium. We have 22.990 grams per mole of sodium divided by the total molecular weight of the compound is 120.054 times 100 gives us a percentage of 19.15%. We'll just say 19.1% sodium. Then we have hydrogen, 1.008 grams per mole divided by the molecular weight of 120.054 times 100 gives us a tiny little percentage, 0.84% of hydrogen. Then we have sulfur, 32.06 grams per mole divided by the molecular weight times 100, which gives us 26.7% of sulfur. All right, now we could do 63.99 divided by blah, 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 times 100, or what we could do is just add up our percentages here and then subtract those from that number we get from 100. So when we add up 19.1, 0.84, and 26.7%, we get 46.64%. But here we're doing actually significant figures, so we get 46.6% total. So when we take that away from 100% minus 46.6, we find that the percent composition of oxygen is 53.4% of oxygen. Oof! So here is our percent composition of sodium hydrogen sulfate. It's of critical importance that you make sure that this equals 100%. If this doesn't equal 100%, there's going to be a problem. You should make sure that this equals 100%. This cannot be more than 100%. Cannot be less than 100% either. It must be exactly 100%. Alrighty, we are all fini, as Ailey would say. Ailey actually says mini. He can't say F, so he says mini. We are all mini with Chapter 10. And we will be having our Chapter 10 quiz, like I said, next Wednesday, which I believe is the 26th of May, 2021. Please work on the 10.3 questions. If you have any questions about the 10.3 questions, please ask me a question about those questions. And I hope you have a great rest of your day. That is it. Bye.